is how we do it.
Hi students, this is Mrs. Bettis here with a short video on how to solve rational equations. First of all, a rational equation is an equation that contains one or more rational expressions. And we've been dealing with rational expressions and we know them to be written in the form A over B. All right, here is the procedure. To solve a rational equation, this is what you're going to do. You're going to multiply the entire equation by the lowest common denominator of all of the expressions. We'll talk about what that means in a minute. Secondly, you are going to solve the resulting equation using algebra. Hopefully, if you've done step number 1 correctly, there will be no more fractions. All right. After that, you will check your original equation to make sure that the solution that you got is not an extraneous solution. And an extraneous solution is a value that is not included in the domain. Let's get into some examples. Okay, our first example is x plus 8 divided by x is equal to 6. So step 1 says to multiply the entire equation by the lowest common denominator of all expressions. Well, the only denominator that we have is x. So we are going to multiply this entire equation by x. So here, here, and here. And once we do that, we end up with x squared plus, well, the x here will cancel with the x in the denominator in our second expression, and that just leaves us with an 8. And that will equal x times 6, and that is 6x. So we've done this correctly. All of the fractions are now gone. Our second step says to solve using algebra. Well, if you notice here, this is a quadratic equation. So we need to use some of our quadratic solving strategies to help us with this. So we're going to set it equal to 0 because I want to try to see if I can factor or something like that. So I'll bring the 6x over and I will write this in standard form. And it looks like I can factor this because the factors of 8 that add up to -6 are 4 and 2. So now that I have my equation factored, I'm going to go ahead and solve using zero product property, and that gives me solutions of +2 and a +4. And don't forget how we do that. We'll just set each of those equal to 0 separately, and then we'll solve. Okay, so that's where those came from, just in case anyone was wondering. Okay, so there are our solutions. Our last step says that we need to check that our original equation, that the solutions that we get are not a part of like extraneous solutions. So we ended up with solutions of 2 and 4. And if I go back here to my original problem, and I'm going to change my color here, let's just plug 2 and 4 in there. So when x is equal to 2, we have 2 plus 8 divided by 2 is equal to 6. This is 4. So 6 is equal to 6. So that checks out. So this is okay. If we were checking the 4, we would have, when x is equal to 4, we'd have 4 plus 8 divided by 4 equals 6. And we have 4 plus 2. 6 is certainly equal to 6. So both of those solutions work out. Great. Do our second example. All right, we are going to move into our second example, and we are going to do step 1, multiplying by the lowest common denominator of all, and it appears that both of our denominators are the same. So we're just going to multiply by the quantity x minus 3 here and here. And once we do, then our denominators actually go away, and we are left with 3x is equal to 2x plus 3. Denominators are all gone. So let's combine like terms, use our algebra to solve. X equals 3. So what we have to do lastly is we have to plug 3 in to check. So let's take x equals 3. We have 3 times 3 all over 3 minus 3 equals to 2 times 3 plus 3, and then again 3 minus 3. Well, looks like we have a problem. So then this is, well, you can't have denominators of 0. So what that says is that 3 is not a solution. It's actually extraneous. So for this problem, there is no solution. You can show that as an empty set. You could show that as a 0 with a slash through it, or you can write the word no solution. Okay, let's move on to example 3. 2x minus 9 divided by quantity x minus 7 plus x divided by 2 is equal to 5 over x minus 7. So step 1, multiply by the common denominator of all. And it looks like it's going to be 2 times the quantity x minus 7 as our common denominator, multiplied with all 3 expressions here. So our first expression, the x minus 7s will cancel, but we're left with the factor of 2. So 2 times the quantity 2x minus 9. For the second expression, the 2's will cancel. We're left with the x minus 7. So it's going to be x times x minus 7. And our last expression will leave the 2 behind times the 5 that's already in the numerator. Okay, all of our denominators are gone. No more fractions. Let's solve using algebra. Distributive property. So here we have 4x minus 18 plus x squared minus 7x is equal to 10. So we're going to combine like terms and solve the resulting equation. So I'm going to put this in standard form. So I'll bring the x squared to the front. The x terms here can combine. So that's negative 3x minus 18 is equal to 10. If you wanted to complete the square, you could, or something fancy like that. But you know what? I'm just going to set this equal to 0 and try to factor. So here I have x squared minus 3x, and here is 28. All right, great. Let's think about that. Factors of negative 28 that add up to negative 3. Yeah, sure. We have x minus 7 and x plus 4 equals 0. All right. And then let's go ahead and solve using our zero product property. That gives us solutions of negative 4 and a positive 7. Well, we need to think about extraneous solutions. And so if we go up to our original problem, and without plugging both values in, let's just think for a minute. What are the excluded values from our denominators? Okay, so here we have an x minus 7. That means that a value of 7 would have to be left out of our denominator. And look at what you have here. We have here that one of the solutions is 7. Clearly, even without checking, I recognize that this x minus 7 is going to be an extraneous solution because it's not a part of my domain. So the only solution I have is negative 4. So if you don't believe me, you can plug those in and check it out. Go ahead and pause the video and do that to prove it to yourself. So this is going to be extraneous. Okay, let's do this last example. So here we have 3 parts, and we are looking for the lowest common denominator of all. Well, let's just take a quick second and factor this trinomial so that we can see accurately what our lowest common denominator is. And it looks like it's going to be n plus 6, n plus 2 going to be our common denominator. So, all right, if we multiply this entire thing by that, and we'll just keep those down there for visibility's sake, and we'll multiply it here, here, and all the way over there. Okay, so when we multiply it times the first expression, the n plus 6 will cancel with this n plus 6, and we are left with n plus 2. Okay, good. Let's move on. Please do not ignore this negative because it's going to be critical. And sometimes that will be the mistake that's made. The negative will be forgotten. But for this next one, it looks like our common denominator is what the denominator is here. So that will all just go away. And so then this is going to be minus n minus 5 and equal. Same thing happens on the other side of the equal sign, and we're just left with n minus 2. All right, let's solve using that good old algebra. So we have n plus 2 minus n plus 5 is equal to n minus 2. So these go away. This is 7 equal to n minus 2. Add 2 and we have that n is equal to 9. All right, let's look at our original problem. Is 9 a part of the domain? It appears that 9 is okay as a part of our domain. We don't have to exclude it. So then our solution is n equals 9. There you have it, solving rational equations. So much fun. I know you guys like this a lot more than graphing rational expressions. That's it.